Hello students, today we will discuss about the question number 8. Which compound on heating with excess concentrated sulfuric acid produce only one product with a molecular formula C7H10? So here we can see the C7H10 is the dialkene. So it is a diene. Actually, in this question we have the three structures 1, 2, 3. Actually here we can see when there is dehydration, this is the diol structures, and if we dehydrate the alcohol in the presence of sulfuric acid, as we know sulfuric acid is a dehydrating agent, so we can see from that carbon OH will be removed, and from the adjacent carbon, either from here or either from here, the hydrogen will be removed and the double bond will be inserted. So in the same case we can see on that carbon OH will removed, and with the adjacent carbon hydrogen will remove, and the double bond will be placed in that situation. So here we can see the only one product should be possible. So if we count the number 1, 2, 3, 4, and here can see 1, 4 dicyclodiebutene hoga, so that will be the from the same side, and from the other side the name will be the same. So here we can see the only product will be produced in the first case. In the second case we can see if we remove the OH from that carbon and the hydrogen from adjacent carbon, so double bond will be placed here, and after that if we remove the OH from this carbon and the adjacent carbon will remove the hydrogen, double bond will be placed here. Only this structure is possible, so this is also the correct. And after that we can see here, if we remove the hydrogen OH from that carbon and the hydrogen from adjacent carbon, so in this situation we can see if we remove the OH from this carbon and hydrogen from the adjacent carbon, so there are two possible structures. So here we can see either the double bond will be present between the carbon this and this, and after that there is also the possibility the double bond will be present here. So in this case there will be two products, but in the first and second case there is only one product, so 1 and 2, so B is the correct option. So in the question number 9 we can see crude oil is the mixture of many hydrocarbons ranging in size from 1 to 40 carbon atoms per molecule. The alkanes in crude oil can be separated because they have different boiling points. The table below shows the boiling points of the some alkanes. Here we can see alkane, butane, pentane, hexane, 2-methylbutane, dimethylpropane, and all these structures. Here is the MR present, here is the melting or boiling point. What is the correct explanation for the difference in the boiling points of the three isomers with the MR of 72? Here we can see this is the 72 MR, here this is the MR 72, and this is the MR. Actually what is the difference between them? So option 1 tells us boiling point is dependent upon the length of the carbon chain only. So we can see the length of carbon chain only. This may be the correct, but we will see the other options as well. Increased branching on the carbon increases the boiling point. No, this is not possible. Increased branching reduces the strength of intermolecular hydrogen bonding. So here we can see the only possible structure. Increased branching reduces the strength of intermolecular van der Waals forces. So in this case we will discuss about the boiling point is dependent on the carbon chain only, so this is not correct. Increased branching will decrease the boiling point actually, so due to the presence of less intermolecular forces or intermolecular van der Waals forces, so D is the correct one. After that, question number 10, the first propagation step in the reaction between methane and chlorine is shown. So how many different first propagation steps are possible in the reaction between pentane and chlorine? So we can see for the pentane and the first propagation, as we know, identification of the propagation step is that if there is present free radical in reactant as well as in the product side, so that reaction will be called as the propagation step. So in the case of pentane, if we can see carbon number 5 chain and the chlorine free radical, and after that on the basis of difference of location of free radical, we can see the three possible isomers of the pentane. So this one, and this one, these three are the possible isomers. So B is the correct option. So after that, the question number 11, the diagram shows the structure of cyclohexene. Here we have the cyclohexene, and what will be the addition reaction with the cyclohexene, the only reactant. Here we can see this may be the addition, and this may also be the reaction, addition polymerization. As we know, for that monomer for those carbon atoms which contain the double bond, those have actually the extra free end carbon. So here we can see the double bond present this, and the carbon is the free double bond and the free bond actually here. So this may be the correct, but this is not correct because actually the cyclohexene, the double bond between these two carbons and after the polymerization, the double bond will be removed and the free carbon single bond will be formed. So in this case there is no cyclohexene structure actually on which that carbon is extended toward the each side. So our option will be 1 and 2. So in the next question, which stage in the free radical substitution of ethane by chlorine has the lowest activation energy? Or we can see here which stage in the free radical substitution of ethane by has the lowest kinetic energy, or we can say the lowest activation energy. In this case we can say this is initiation, this is propagation, this is also propagation, and this is termination. We can know that the termination step is the only step in which the lowest activation energy is required. As we can know, at the termination step, the free radical substitution will be ended in this step, and there will be very less amount of energy required to start the reaction, and actually there is end of the reaction. So termination is the correct option. Which synthesis will be successful? Actually we can see here which reaction is possible actually. So we can here see that the propane is formed from the propene with the help of LiAlH4, lithium aluminium hydride, actually with the help of reducing agent. There is no alkene can never form alkane, so 1 will not be the correct option. In the option 2 we can see alcohol from the ketone. As we know, there is order of oxidation is alkane, and after that alkane there is al formation, we can know aldehyde or ketone, and after the ketone formation, so after the formation of alkane there is ol formation, after that al formation, and after that oic formation, we can see the carboxylic acid formation. So alkane, alcohol, aldehyde or ketone, and after that carboxylic acid. So this is the order of oxidation, and NaBH4 is the actually the reducing agent. So we can say ketone will be reduced into the alkane in the presence of NaBH4 or alcohol. Both are correct option. So in the same situation here, aldehyde can also be reduced into the alcohol. So 2 and 3 are the correct option. So C is the correct one. So question number 14, when heated with the chlorine, the hydrocarbon 2,2-dimethylbutane undergo free radical substitution and the X will be formed. How many different X are the formed? Actually here we can see the X, different X. We can see the free radical on this carbon, or we can see free radical on this carbon, and after that we can see the free radical on this carbon. So only 3 different possible structures are possible. So option B will be the correct one. We can see, as we can see, the product will be C on this free radical can form, and after that this free radical can form, or in the next case there will be here free radical can form. Only three options